Hey everyone, my name is Atul Gupte and it's my colleague Felix. We're here from Uber and we're very excited to talk to you about how we're building intelligent applications and enabling experimental machine learning with Uber's data science workbench. So let's get started. So a quick overview of what we're going to be discussing today. I'm going to walk you through what makes data at Uber so exciting and challenging. I'll take you over the analytics stack so you understand sort of how expansive it is and all of the technologies involved. We'll then speak a little bit about Spark at Uber and how it's very pervasive across all parts of Uber itself. Similarly with machine learning at Uber and how that feeds into pretty much every single thing that we do. Both these things are very foundational for what Uber does. Felix will then talk you through the Data Science Workbench, which is a tool that we've built to help teams make sense and take advantage of all of these tools and technologies. And then we'll finally walk you through a few common user flows, as well as some of the impact that we've had, and that some of you may have even seen when you use the Uber app. So with that, let's get started. Like I said, my name is Atul. I was an engineer before this at Zynga, where I helped build games like Farmville and Words with Friends, as well as their mobile advertising platform. Here at Uber, I'm a product manager currently for the Data Science Workbench, as well as Uber's data warehouse. My colleague Felix here, he is an Apache Spark PMC and Committer engineer and owner of the Spark area at Uber. So like I said, let's kind of get started with data at Uber and what kind of makes it such an exciting place to be. So Uber's mission is to bring reliable transportation to everyone, everywhere. And we use data to make this happen. Data informs literally every decision that we take at the company. Our data is massive and it holds deep hidden insights. And the job of my team is to surface these insights. There are over 6,000 people, data scientists, engineers, operations managers all over the world who rely on us to support the business. They rely on the tools, technologies, and the platforms that we build to derive these insights and to actually apply them in the real world. So data at Uber is very different. Data differentiates Uber itself, but it's unlike anything anywhere else in the world. And let me explain what that means, right? So what makes Uber unique is the business itself. Our business is, we're a mobility platform, a low-margin business with a delicate marketplace. We're actually moving things in the physical space, right? So we're moving cars, people, food, trucks, bikes, all sorts of things in the real world. So when you press a button, there's actually something physically moving. We're spinning up new lines of business in an instant. So when we acquire a new company, we acquire Jump. Now all of a sudden we have bikes on the platform. So our platform needs to be able to handle all of these things happening. Our analytics are also very different. They're real time and real world. So every query that you run actually impacts something that happens in the real world, right? They're spatiotemporal. In space and time, things change very rapidly, and our platforms need to handle that and surface those things. Because of all of this and because of the sheer scale that we operate in, which is about 600 cities, 65 countries, all over the world, every time zone, we really need machine learning to make sense of all of this. So machine learning almost becomes our brain. And finally, our consumers are also a very key differentiator, right? So like I mentioned previously, we have over 6,000 data scientists, engineers, and operations managers. They exhibit varied skill sets, right? And they have varying desires and varying needs from the data platform itself. So some are doing just business intelligence, others are building deep neural networks, and they're all sitting together, working together to solve the same problem. And finally, our customers are also external, right? So it's not just internal Uber employees, but with tools like Uber Movement, where we share our data and insights with city governments, we have a completely different set of users and use cases. So our data platform really needs to scale not just in size, but also across all of these various spectrum. So that's what brings the data platform team, right? And that's what my team does. We're responsible for moving the world with global data, local insights, and helping them make intelligent decisions based on all of these things. So to make this happen, before we talk about the various things that we're doing and building, I think it's relevant to walk you through sort of the analytics stack that exists and that these people are working with every single day, right? So the data team that provides services and analytics is kind of split into two. We have the data platform side of the business as well as the data infrastructure side of the house. So pretty self-explanatory here on the infrastructure side. These are the teams that build and manage the systems that produce the data, ingest it, model it, store it, disperse it, and then also manage the workflows that make all of this happen. And on the other side of the house, we have, of course, data platforms. And they're building the tools and services that enable things like business intelligence, visualization, ad hoc, streaming analytics, experimentation, knowledge management, and of course, machine learning. And they're all interacting with the foundational infrastructure that the infrastructure team has provided. So what really does this infrastructure look like, right? In typical Uber fashion, it's large and it's fairly complicated. So on one end, we have systems like Kafka, Schemaless. These are systems that handle all of the data coming in from our various apps, from data sources like weather data, traffic data, and all of the various data sources that we use to bring data into the system, right? So all of this system is available in our streaming and real-time systems as well. So we have Apollo and Athena X that users can actually query in real time. So if you want less than 5 minutes latency to see what's going on in the world right now, we have use cases that require this. This data then lands in our data lake, where we have raw data, we have some raw tables, and then we also have a team that does modeling on these tables to make them more effective and more useful. We have engines like Hive, Presto, and Spark to make sense of this data, to run queries, to do stuff on this data itself. And then finally, this data, or at least some parts of it, all of the model tables and some of the raw tables, they land in Uber's data warehouse. And this warehouse is there for a reason. It's optimized for very low latency querying, and although the data is a little stale, it powers a lot of our analytical operations, right? And of course, if you have systems of this size and scale, you have the usual problems, things like making sure they're secure. With GDPR coming in, that's obviously much more important now. To make sure they're all active, we have multiple data centers. We want to make sure that data is consistent across all of them. We have things like observability, right? Make sure we understand what's going on at any given point of time in all of our clusters, and of course, cluster management to make sure that clusters are healthy, performant, and are serving the needs of all of the various use cases. And talking about the use cases, so if you remember from the previous slide, we had a bunch of different data platforms initiatives, and they're all relying on this infrastructure, right? So right from our experimentation service, our machine learning platform, our various apps, business intelligence engines, we have ad hoc querying, we have a notebook service. So they all kind of rely on this infrastructure to power all of their services. So I think this is a good segue for us to go into Spark at Uber and how it's foundational. So Spark is pretty foundational at the company. It's very pervasive, and just to get a quick sense of scale, right? So we have over 100,000 jobs every day. 96% of our ETL pipelines use Spark in some way or form, and over 98% of our resource usage also is on Spark, right? So we have 11,000 plus machines in multiple data centers that are working on tens of petabytes of data, and in one of the largest HDFS clusters in the world. So Spark it's not a small thing, right? Like it's all over our company. It's very pervasive, and to make better sense of this, to help developers use this more efficiently, we built something called the Spark Compute Service. And like it says, we're simplifying the lives of not only the developers, but also the cluster managers and operators, right? And a couple of important reasons why we decided this was something that we wanted to do and build, right? So we wanted to consolidate our infrastructure, make it available across multiple data centers that we have, improve our experience by standardizing builds across users, allowing them to bring in their own stack if they wanted to, but also giving them things like monitoring and debugging, which would be kind of hard for them to do on an ad hoc basis. We want to enable multiple use cases. So like I mentioned, we have a large number of users across the spectrum, and they're doing things like exploratory stuff, bursty stuff, batch jobs. And then finally, we want to make it even more widespread across the company. So for that, we want to do better language support for various interfaces. So this is something that this team was built to do. So if you missed this yesterday, my colleagues Karthik and Bo spoke about Drogon, our Spark Compute service yesterday. So maybe watch the video if you can. I think they go into a lot more detail than I can today. So now we spoke about Spark, we spoke about our data analytics stack itself, and I also did mention that machine learning is very, very important, very foundational to the company, right? So I wanted to talk to you a little bit about that and give you a sense of what that really means, right? So of course, quick primer, on what the hype is about machine learning. Quite simply, ability of your machine to learn without being explicitly programmed, to identify hidden patterns. That's exactly what we're trying to do with all of the massive data that we have, and use this to predict the future. And of course, when you say learning, you want the machine to get better at its task. So if we give it more data, more experience, it needs to learn from its mistakes and get better. So essentially, that's what machine learning is. But when I say it's pervasive across the company, right, it really is. It goes into literally every single piece that the company puts its fingers into, right? So this is a typical workflow of what an Uber trip looks like. I'm assuming all of you have taken a trip at some point. But yeah, so right from ordering a car, we use it to do things like demand prediction to figure out where these vehicles need to be positioned. If it's a self-driving car, it does things like route planning, motion prediction. If you've ever taken an Uber pool trip, we use machine learning to figure out where to cluster the pickups. Now, once you're in the car, remember there's no driver, so we need some sort of voice recognition to figure out where the passenger needs to go. We do things like supply modeling and occupancy modeling to figure out who's in the car, and use that for various things downstream. Now, once you're in the car, you figured out you're going to a Mexican restaurant. The car needs to plan the route, provide the user with an ETA, figure out what are the road conditions. Are we going into high traffic area based on past data? Use that to kind of optimize the trip, right? The next one you see where we're doing things like elasticity estimation, right? So what is the do you think this passenger will be willing to trade off time for a cheaper trip if we can go and pick up someone else, right? So that's what's happening over there. And if the rider chooses to accept, we need to, again, replan our routes, optimize those again. So again, machine learning comes in there as well. And then finally, once the trip is complete, we're doing things like speed generation, NLP for support, and many, many more. I mean, these are just a small subset of things that we're using machine learning to power, but I just wanted to give you a sense of how pervasive it is in something as simple as ordering an Uber and taking a ride, which is such a common operation, right? So as you can imagine, the typical ML workflow, 4 major stages: defining the problem, prototyping it, productionizing it, and measuring it, right? So this is something that teams do iteratively to kind of build an ML model, right? And so on the definition stage, customers work together, they define objectives in a cross-functional team, they do some data-driven research, they pull data from various sources and define what the MVP needs to be for this particular model, right? Once they go into the prototyping stage, it's getting data using SQL or Spark, cleaning it, using GPUs or CPUs to train these models, and then finally evaluate them, to validate these models, determine the computational complexity, and things like that. Once they have sort of a valid prototype, then is the most important part, which is productionizing it, actually getting it out there into our apps, into our systems. And what this requires is, of course, engineers to productionize the model, to deploy it with our experimentation engine to make sure the rollout is smooth, and then finally using it to make predictions, either in real time or in batch, depending on what the specific use case they're trying to solve. And once we have the model out there, of course, we want to gather those insights, monitor those predictions, make sure there are no degradations, and do some deep dive analyses to inform what our product roadmap needs to be like to take advantage of all of these insights that we derived. So our world in 2016 was very different, right? So our data science community was growing very fast. They were all using Python and R to do machine learning, but it was mostly do-it-yourself, on their own laptops or on whatever hardware they'd cobbled together. Moving these models to production was incredibly hard. There were a lot of tools and libraries, and as I said, teams had built their own infra, but none of this could kind of scale to the levels that we needed. Collaboration and sharing was non-existent because that's not something that had been thought about when you're cobbling together systems. And of course, security, compliance, these were things that did not exist in our vocabulary at that point. There was just no time to kind of build these things out. And so given this background and given how foundational we believe machine learning was at Uber, we decided to build a new product called the Data Science Workbench. We have a blog post on our blog, eng.uber.com/DSW, so I encourage you guys to check it out, but we'll be talking about this a little more as well. And quite simply, the mission was to unleash the productivity of this data science community by giving them the infrastructure, tools, customization, and the support that they required to build these foundational products and make such a large impact on Uber. So a quick schematic of sort of what this world looks like. So it's a completely browser-based environment where users can log in and run their RStudio, Jupyter, or Shiny sessions. It's backed by a robust management service that does session management, file management. We manage packages, updates to those. We allow for some collaboration. We enforce quotas so people are not clobbering on each other's resources, and provide this as sort of a service. Now, each user session is on a Docker container, and it's completely isolated from other sessions. So whatever you do on your session doesn't bring down what everyone else is doing. If you write bad code or whatever. And these are backed by distributed persistent storage, so even if your session does go down, you're not losing your work. This facilitates things like file sharing, collaboration, commenting on files, tagging things. And most importantly, this session that you create has access to the entire infrastructure stack that I showed you a few slides earlier, right? So if you want to do batch analytics on Hive or run real-time queries on Pinot, or do some business intelligence and run those queries in Warehouse, do some deep learning with TensorFlow on GPUs, or do machine learning with Spark. You can do all of this in a single interface. And the power of this is that everyone's now working together, and you don't have to keep switching between tools, learning new paradigms. You can do everything in one place. And that has actually brought about a foundational change in the way data scientists work today, right? So today, our world has fully hosted environments. You don't have to install anything. You just go to a browser and get started. We have pre-baked environments, so they have everything that a user needs to get started, but you can also bring your own packages, right? Bring whatever tools and libraries that you need to make your work better. Like I mentioned, it's wired to all our internal compute engines. We allow for Shiny dashboards, so we can publish one click and enable sort of complex analytics. Multi-data center, secure, GDPR compliant, these are all things that just did not exist in 2016 before this product came out. And finally, we have a team that offers support and documentation. So pretty foundational change in the way, foundational shift in the way teams are now working. And to talk to you a little more about this, my colleague Felix will do a quick walkthrough and talk about more exciting things.
Thank you. So let's take a quick look at Data Science Workbench. So this is the main interface. On the right, you see the detail of the session that is selected. On the left-hand side, you see a list of sessions that you currently have. You can manage it. You can create multiple sessions and manage it, run it concurrently at the same time. You see on the top 3 different tabs. So we're looking at the session tabs. And you can click on the individual session to look at, like a very common familiar view that you probably are really familiar with, like a Jupyter interface or RStudio web interface. But you go back to the second tab, you can click on the Files tab. You can take a look at the list of files you have. That's actually stored in this distributed file system storage service that we integrated with Data Science Workbench. And then you click on the Job tabs, you can actually have it manage the different session and then have it running in the schedule time using a cron notation. So the idea here is you can actually do this to schedule retraining on the machine learning model you have, or you can do lightweight batch prediction, or you can actually just simply run and refresh the data to plug into your dashboard. So if you go back to the top, you can click on the dashboard tab, and this is kind of a way we can build really expressive analytical dashboard with like capability. You can drill down into different time and place dimension, and using this visualization engine called Kepler GL that we open source, and it's a geospatial visualization that's really, really helpful for something that we do at Uber, looking at different trips and different cities and so on. So in terms of scale, we actually run hundreds of these over dozens of thousands of views per month. And plugging this into the Data Science Workbench makes sure that these are all always up to date and has the fresh data that people can go and operation can be supported using these dashboards for drill down and analysis and all sort of stuff. So for now, let's switch gear back into talking more about Data Science Workbench and Spark. So let's take a look at a quick look at the architecture. So you see on the right-hand side, I guess I have the left and right flip, but see on the right-hand side, you can see the data science workbench, and what we talk about the architecture with different container running at the same time, possibly Jupyter and RStudio running in the container. We also have the storage service plugin integrated with the data science workbench. And then further on, what we do is actually use something called Spark Magic, a package that is available right now, and have it integrated to the Jupyter interface and connect to the Spark compute service that we talked about. And what we're doing in this architecture is to quickly expand the available resource available for you, for data scientists, to look at data set by connecting basically the workbench and the cluster system together. So let's take a quick look at some of the primary use cases of data science workbench before we dive into more of the specific scenarios. So one thing we want to do is using the workbench and connecting to the Spark compute service so that you can actually explore the very large-scale data set that you have. The other thing we want to do is parallelize Python native packages and have it run and for things like feature generation and model training. Another thing that we do is having this as a common interface to enable teams to do ad hoc analysis, prototyping, or building proof of concept, and just looking at the machine learning model so that before they bring in production, they can evaluate and take a look at the performance and reiterate and have this way to actually validate the result before going in. So here's one of the top common pattern we see in the company. So as you can see, we have most of our data set in Hive table. We're using PySpark to extract the data and doing it at scale and pulling the data set. And this is kind of a very important thing because that's PySpark enable you to do iterate and manipulate and take a look at the data and get a sense of what does it look like, how do you do some exploratory analysis on it. So one thing people commonly do is using PySpark to do some analysis based on the statistic of the data itself and doing some data cleaning and data preparation. Once that is done, that gets parallelized and feed into the native Python packages through what is supported by PySpark itself. A very common thing to do is actually just run scikit-learn in parallel through hundreds or even thousands of nodes. And then when that's done, the data is collected back to PySpark, and then we persist it and store it in the Hive table as well. So feature generated by this is actually going to be feed into machine learning training process itself. A slight alteration in something like this is that we could also use scikit-learn or other native Python packages for distributed model training through some kind of data parallel architecture. Another alternative that we've seen a lot is actually using not Python, but Scala. So one thing you can do is you can do the same thing for data preparation and manipulation upfront transformation. But once you get to a point where you're satisfied with, you use Scala and then using the Spark ML-lib machine learning pipeline to train the data set at scale using ML-lib for distributed machine learning model training. And then you can evaluate the result you get and, like I said, also reiterate until you're satisfied with it. Once you're satisfied with it, you can persist the model into storage in the form of XGFS, and that would be made available for production use for like serving and scoring and so on. So let's dive into some of the selected experience that we've built using an architecture like this through Data Science Workbench and Spark. So you might have heard from our CEO, safety is actually one of the #1 company priority. So what we do is we look at trip statistics and also try to do some machine learning model analysis to see if there's instances that we should detect and should be aware of for your trips. One thing that you might not be aware of is we also do a lot of food deliveries, so in the form of Uber Eats. So if you're not a user of Uber Eats, one of the challenges here is how do we get people to use Uber Eats more, right? You may be a user of Uber itself for your trips, but you might not be aware. So how do you solve this problem with cold start, right? We have no information about you. We don't know what you want. So one thing we're doing is using Data Science Workbench and Spark to basically build this recommendation engine to solve this co-source problem and actually give you some recommendation based on a number of criteria that we have about things that we might know how you're using Uber for trips. The other thing, with a company at this scale, where, as you may have guessed, we actually spend a lot of money looking at supporting, looking at support ticket and doing support in general. So one thing we actually do here also is using this architecture is to visualize and evaluate and train model that will analyze the support ticket that's created, and using NLP to effectively route the ticket that's created to the right agent, and to ensure that we have a quick response time and reduce the cost of the support we do. Another thing we do is looking at driver referral. Driver referral is a very important thing to ensure there's a healthy ecosystem. We have more driver on the road, that you can actually get a ride really easily and so on. One thing we want to do is actually looking at some of the metrics and characteristics we have about the driver referral cases we have, and looking at scoring on the risk factor, and ensure that you have a good experience as a user, that you don't actually get in a situation where two drivers are, there's some abuse situation in there. And one last thing I want to talk about is operation. As we talk about, we are operating over 600 cities all over the globe, and operation is a huge aspect of this company. So at Uber, what we do is also build something called a lifetime value model, so that we can actually facilitate looking at how do we optimize operational aspect in each individual city. There are many, many more exciting, interesting use cases we build on top of Data Science Workbench and also Spark. But we are looking at great engineers to join us and help build us. So we're looking at engineers at San Francisco, Palo Alto, Seattle, Bangalore. Go to this URL, check us out, contact with us, and that's it. Thank you.
Good lineup for the questions.
Hi, pretty good talk. I saw you were using Livy or Apache Livy, or did you also use Spark Job Server?
We don't. We're using Livy for the job management and the compute service, yes.
Do you see a lot of issues, or it's pretty good?
We're okay so far.
Okay.
I mean, it's we also implement a different backend for basically failure handling and things like that that we haven't upstream yet, but this is something we're looking into.
Okay.
Yeah, so Apache Livy is an incubator project in the Apache Software Foundation, and that's actually what we're using for the compute service we're building, yes.
Okay, thank you.
Yeah, are we doing it? Right.
Thank you for the talk. Really good presentation. Do you guys plan on open sourcing this project?
Great question. We will get back to you on that.
Oh, yeah. Second question.
Yes.
Can you elaborate a little bit on how you productionalize these models from the Workbench? You mentioned that you save the model to HDFS. Do you follow any particular CI/CD policies or?
So this is a much more involved question. I think feel free to kind of follow up with us after this question, because it's actually many different dimensions. Right? It depends on how the model is built, how to operationalize it is really different. Like for example, if you build these models using Python, then you kind of need to get Python into the pipe before you can operationalize it or actually serve the model that way. So that's one aspect we're actually actively working on. There's a whole initiative in the company working on the end-to-end lifecycle experience using machine learning, and we're part of this process of thinking through how do you take it from the data science exploratory stage to production. So for Python, it's a whole different initiative, but for things like, for example, this example I have with training a model using MLlib, right? So if you take that example, the model is trained using Spark. So another initiative I'm working with the community on is how do we effectively take the model that is trained using Spark and having it plugged into a serving system for production. So today, right now, we serialize in a special format that we actually load this up and then plug into the Java system that we build for serving, that plug into the production system that way. So that's kind of how we do it. Is that kind of answer? If not, then we can kind of go into different aspect of it after this. So next question.
This is Rakesh. How do you guys handle GDPR data deletions in your platform?
Oh, great question. Maybe
Sorry, can you say that again?
GDPR data deletion.
Yeah. How do you guys handle the GDPR data deletions?
Data deletion. Interesting. So I think as a compute platform, that's not really something that we handle as much. You know, it's handled. There are multiple other teams that manage things like knowledge or the data lifecycle and you know storing the data in various systems. So we let them do their job and kind of handle the GDPR stuff.
Let me touch on that a little bit. I think as you are aware at this point, we talk about the whole entire data platform and data infra space we have at Uber. So there's actually many teams involved in this, right? Many different aspects of it. We've done a lot of work in the data ingestion side in terms of handling these data as they come in. How do we remove things when it has happened? And how do we go back and actually remove as required by GDPR and going in? Now, we're not really the experts in this space, but it is actually a lot of work we're going in terms of looking at the data set we have on Hive and how do we go and update them as it happens. So we can take it offline and talk about it. This is sort of, the good news is we actually do it in such a way that's completely transparent to data scientists. Okay. To data scientists, you don't have to know how this works. Like you just use the data. But obviously, a lot of really hard work is actually done under the cover. So I think we have somebody, our colleague here, can talk to you more about the details of all the magic happened in ingestion and afterwards, and how do we handle these changes and so on. It's a really complex system that we really should have another talk to talk about at one point. That is also actually built using Spark as well. Anyway, so yeah.
Thank you.
So we can take that offline.
So we're running out of time, but
okay.
We can find our speakers offline.
Yeah, so we'll be here and we can talk more about it.
Absolutely.
Right. Thank you.
Thank you.